I'm gonna go off mic for a second. Okay, hopefully you can hear me. I'm not sure if everybody's back, but give about another 30 seconds or so. Okay, so I'll probably get rolling, and I do feel your pain because I mean you just sat through 2 hours worth of grind, but hopefully it wasn't that bad. Hopefully you went with enough insights from office hours and a pre-lecture that it went a little bit quicker. Yeah, everything's the same. AAMC hasn't changed anything for years, and so same thing, same errors, same everything. So it's not a bad idea to do them again, just because, especially for cars, there's nothing even close to as realistic as AAMC. Just don't take the score seriously. And is your account still alive? Yeah, I mean, there's a good chance that's true. I mean, you forget some of it, but the thing is, always in the back of your mind, there's some little thing like, oh yeah, this one has this. I need to look here, look there. So you are biased, no matter what. There's still some sort of bias, which is big reason why when I go over them, I'm going to turn into complete a-hole jerk mode, because I don't want anybody to have their experience ruined. So hopefully it ends up okay. But it's like when I go over AAMC materials, I'm definitely going to make sure that you've done them. You can show you've done them, and then you're good to go. You're invited to the party. Okay, so starting into this one, looking for the acetate anion concentration, and so the first thing we need to do is look at what we mix together. So if we mix an acid and a base, and more specifically, an acid with its conjugate base, an acid with a titrated base, a base with its titrated acid, what do we mix here? So what are the two components? HOAC is a perfect weak acid, exactly. And what's NaOH? Strong base, perfect, exactly. So we mixed a weak acid known as acetic acid with a strong base. Because the base is strong, it's going to completely react. So I'm going to solve this two ways. First, the icebox, and then the intuitive way. My goal is that if you trust the icebox and it works out and you believe it one time, you're going to be more apt to take educated shortcuts in the future. So starting with the icebox, the two reactants, the weak acid reacting with the OH minus, I'm going to ignore sodium. It's going to turn into the conjugate base and water. So initially, I have 20 times 0.3 or 6 millimoles, because reactions, we deal with moles, so millimoles. And how many like me are bothered by millimoles, but it beats 6 times 10 to the minus 3 moles? Yeah, I hate that term. I don't know why, but as long as I have consistent units, yeah, I think every living soul probably does hate the term millimoles, but it beats 10 to the minus 3. And so I've gotten used to it and, if you will, gone numb to it. 3 times 10 is 3 millimoles. And again, just make sure my units, moles per liter times milliliters. So liters cancel liters. So you're left with a milli and a mole. Because it is a strong base, it's going to fully react. So I'm going to lose all 3, which consumes 3, adds 3. And why do I not care about the water column? Why am I going to be completely ambivalent? Water is irrelevant. Water, the little bit of water you get from the reaction is nothing compared to the solvent. Yeah, it doesn't add anything to the reaction. Basically, it's a product that is already there in high quantity. So in the end, I'm going to have a 3 millimole quantity, 0, and 3 millimoles. And so they're asking for acetate anion, which is this one right here. Actually, you know what? I'm going to color coordinate it. And so the molarity, the concentration of OAC minus, what are the units of concentration? I've already forgotten. Moles, perfect. So I'm going to go with 3 millimoles. That's the moles of OAC minus that formed from that reaction, divided by, what's the new volume? Why 30? (20 plus 10), exactly. So millis cancel, moles per liter moles. So it's going to equal 3 over 30 molar, which is 0.1 molar. Okay, icebox works, everything's well and good, and I finished in what, about 3 days? Is that a good pace for the MCAT, taking 3 days per question? Not going to work. Perfect for studying, great for studying, get it down pat, not gonna help you on the real test. So let's consider what happened here. The icebox told me about the dilution or the reaction. It told me about the reaction. The icebox is what reacts and what you get. And do you agree this 30 was because of the dilution, adding 20 and 10? So the concentration is being affected by two aspects, the reaction and the dilution. So the dilution factor, do you agree, is 2/3. Where I come up with that is, you start with 20, you finish with 30. So you agree just based on diluting it, it's gonna be 2/3 the original concentration. And then the reaction factor, how much of the HOAC is being converted over to OAC minus? You start with 6, where you go down to 3 and go up to 3. So the original 6, you agree half of it is converted over. And you can get that from the fact that have I added half an equivalent? They're the same molarity, but 20 milliliters and 10 milliliters. So you agree I've only added half an equivalent, half the amount I need of base. So the reaction, you're only reacting half of it, and you're diluting by 2/3. So 1 times 2 over 2 times 3 times the original concentration of 0.3. So let's cancel what we can. 2's cancel, 0.1, 0.1 molar. How many are okay with this approach, considering the two factors, dilution and reaction? Half an equivalent plus 2/3 dilution, 20 over 30. Is this a faster way that is doing the same thing, but more organized, more conceptual? So the key thing, if you believe this, and you need to do a little bit of review to convince yourself this is correct. Once you know the icebox is going to do this for me, can I just cut to the chase? If they're asked for a concentration, how much is associated with the reaction and how much is just getting diluted by adding a new solution in there? So does this seem okay? Does this one seem fine to you? And I know for some of you, this is your second or third time seeing it, which hopefully helps a little bit. Oh, okay, so here's the question that's been brought up. Why is it wrong to think that the strong base is half an equivalent, so the concentration of the anion will be half? That is true from the reaction factor, that if you added solid NaOH, if you added 1/2 equivalent of solid and the volume stayed the same, it would be definitely half. So your half is right here. But the other thing's happening is two things are going on here. You are both reacting it with the half you got, but you're also diluting it by adding 10 more milliliters, making the volume go up. When the volume goes up, concentration of everything goes down. And so it's that it's not wrong to think what you're thinking. It's just not complete if you're looking at it that way. Well, does that make sense that two things are going on? The reaction you described, definitely half equivalent, means half is converted over. That's why half the 6 millimoles are converted over. But there's also a dilution factor by mixing two solutions together, making the volume go up. So does that make sense that that's the other thing? That basically, this part, you're absolutely right, but there's one more thing going on. Perfect. Okay. It was asked by multiple people, although one is not here, but I'll still go into it. NMR. So I'm going to try to do NMR, and again, I'm doing it my perspective. So kind of what we did yesterday, that whole idea of like finding a needle in the haystack. So let me revisit that notion. Here's my haystack. Here's the metal pipe that we always have in the middle of every haystack, kind of a random thing. And here are the two needles I'm looking for. So the basic notion I'm going for NMR, again, anything moving in a linear pathway will create a radial magnetic field. Anything that's spinning will create a linear magnetic field. So nuclear spins are like needles. They're tiny magnets. Do I need the same magnet, same size big magnet to find the first one as the second one? So let's just call this A, and this one B. Do I need the same size? Oh, sorry. Trying to draw some hay in here. Do I need the same magnet to find both? I would agree, big magnet will find them, but you agree this magnet because it's further from the metal. So will this pipe interact with the magnets at all? Sure. So would you agree I need a smaller magnet to find B and a bigger magnet to find A? So I can distinguish A and B's relative distance from this important pipe or metal material in here based on what size magnet. So basic gist is this: NMR is using a really big magnet to find a really tiny magnet, the nucleus of hydrogen. So just out of curiosity, why is it 1H that we're looking for? So why can you not do helium? Actually, let me put the two in the right spot. So why does this one work, this one not work? Two spins. For helium, you would have spin up, spin down, no magnetic moment. This one you have it. So because there's an unpaired, we can find hydrogen. Helium we couldn't find. Not that helium would be helpful anyway because it's inert, but basically I'm finding a really tiny magnet using a really big magnet called the NMR machine. Okay, so with that in mind, ooh, Jonathan, thank you so much. You are on top of it. Thank you, my friend. Okay, so moving on, you are getting pretty quick at it. So you definitely need to put that on your application when you apply to med school. You were official co-host attendance monitor for Berkeley Review. In fact, we'll send a bumper sticker out if you want to put it on the back of your parents' car. My child was student of the month at Berkeley Review. So perfect. That just seriously prestige on that one. Okay, so one of the most common questions they like to ask is basically how many signals you were going to get, which is another way of saying how many different types of hydrogens do we have? So is it worth drawing out the structure for a lot of these questions? Does that help at all? By all means. So cyclopentanone, 5 carbons in a ring, ketone at carbon 1. So the ON, the most oxidized carbon, defines carbon 1, couple methyls. So make sure this is correct. So I got carbon 1, 2 dimethyl, 3, 4, 5 membered ring, this one. Why am I not giving that a letter or that a letter? Why do I have an E and F on there? No hydrogens, perfect. So my hydrogens are A, B, C, and D. Why are these two equal to one another? They're on the same type of carbon. Both these carbons are connected to the same carbon, so they're iso. One is above the plane, one's behind the plane, but they're both equidistant from the carbonyl. C is different from the rest, A is different. So which one is closest to the electron pair, by the way? So which one is closest to the magnetic field emanating out from the O? A. A is going to be the furthest down field. B is 2 away, B is 2 away, C is 2 away. So are these all going to be kind of jumbled together, but this one is right next to it? So A will be furthest downfield, the other ones will be kind of a mess, but perfect. Okay, so the key thing, first question is how many unique hydrogens? 4. So for this one, 4 non-equivalent carbons that have hydrogens bonded to it. So there are 4 unique types in a ratio of 2 to 2 to 2 to 6. Okay, that's starting point. Okay, so free to click from this one. So we have a real basic, 4 different types. So I need 4 different magnetic field strengths to detect those 4 H's.
Todd,
Okay,
really
so
quickly,
yeah.
sorry, why wouldn't you label the methyls A and then go around like that? Like, is there a reason why you did the A on the left side first?
Oh yeah, no, not at all. So
Okay.
in interesting. So let's go back to that. Let's say for some reason I decided to just and like a little bit on the different side. Let's say I labeled these Q, W, Z, and D. As long as you're labeling with 4 different things, that's all that matters. So I have no idea why I did A, B, C, D in that order. If you want to do it in reverse order, that's perfectly fine. So as long as you're identifying unique different types, that's all that really matters.
Okay. And then would you be
Okay.
able to explain why, well, I guess in this now scenario, I think it's D that you put there is closer to the carbonyl rather than the methyls? Because technically
Oh,
they're like basically the same distance away.
are they the same distance? So let's consider. So here's the carbonyl carbon. This is 1 carbon away. These are 2 carbons
Oh,
away.
I see. Okay.
So it's like that. And yeah,
Okay,
there are
that makes
some
sense.
good videos out there. And if you find good videos, and this is the thing I love about Discord is you guys are sharing good resources, because there's a lot of good stuff and a lot of crap stuff out there. And from the look of things, so were those posted? Okay, so it is in Discord, perfect. Yeah, it just, yeah, so yeah, those are the kind of things. The more you guys post and help each other, the better. So, and again, it's one of the things that I was talking about yesterday. I think even talked about to one of you and then also my wife. Want to just say something, Jonathan? How quick are you, Mr. Speedy, on letting people in? By the way, so my thing is frozen. Oh, there we go. No, one thing just want to take like a 30-second little timeout to say, you guys are starting to really kick ass. This is that climb that you get. So I've seen this and I've seen this the last few days. You guys are asking some really smart questions and really starting to solidify how you're doing. It's completely noticeable. And sometimes adversity brings out the best. And so all the crap, I think, how many are just tired of being pissed off and just now it's like working together? You become your own best resource. And trading ideas, good videos, helping out. But seriously, your answers are solid. And I actually hung around far longer in today's lecture to just see how you guys were doing. You guys were nailing it. It was really cool to watch that you guys are getting your stuff down pat. So in spite of all the periphery crap, you guys are still zeroing in. And how many are actually noticing it? How many notice in your peers and in yourself? It is starting to click. You are starting to get a lot of this stuff. You clearly can say, I'm smarter than I was 4 weeks ago. And you gotta check in like that. Although still a ways to go, but it's been pretty cool to watch. It's been cool to see this. Yeah, and it's because you're working your butts off, but you're also really supporting each other. I seriously think this is because of you guys. Nothing we're doing, but this is all on you. Wow, so cool. An increase in phase is, I mean, you're going to get a few really good phases in there. And it's going to feel really good when it happens because you get sick of being beat up. So that's pretty friggin' awesome. So that's so awesome. Okay. Onward we march. Yep. Seriously, thanks to everybody here. You guys are, I mean, if I could wish anything, it's that you guys stay in your Discord group when you apply to medical school, when you go through everything. Because you will be each other's best resource and best ally. And I hope some of you end up being classmates for 4 years. I seriously, that would be such a happy thing. Anyway, that said, 3 things I'm going to worry about. One is called the shift value, which has to do with the strength of the magnetic field. So again, the closer the needle is to that metal rod, the stronger the field you need to detect it. The closer an H to an electron-rich or magnetic-rich is the correct word, environment, the stronger the field we need. So it measures basically the magnitude in what we call ppm, parts per million of the total magnetic field relative to a standard. So it's an arbitrary scale, it's all relative, so it really doesn't make a bit of difference except within its own numerical value. But let's go ahead and consider. So how many unique types of H's on this one? Three, perfect. This group, and this group. Here's my carbonyl. This one's 1 away, this one's 1 away. So these 2 are 1 carbon away from the carbonyl, this one's 2. So are A and B going to be similar and is C going to stand out? So which ones will require the strongest magnetic field to find? A and B or C? So A and B are just one carbon away from the carbonyl. C is a little bit further away. So A and B will end up so-called downfield or higher ppms of the magnetic field to detect it. And then this will be C. So I can safely say this is C. Which do you think is going to be a little bit harder to get to, A or B? So what's your gut feeling? B. Got a little bit extra electron density in those bonds, which means B is a little bit higher. So I'm going to guess B and A up here and C down here. So C again is isolated, easy one to get. B and A a little bit trickier. But I at least know anything next to a carbonyl, alpha hydrogens, are anywhere from 2 to 2.5. So these fit in that range. And anything that's alkyl, a little bit further away, is 1-ish. Okay, so I've memorized a few numbers. I'm feeling good. This part is done. I am convinced that this is going to be the furthest downfield because it's near the O, like A, but also has a little bit extra density here. Okay, besides the shift, there's also the area and also the splitting. You need to consider both. So coupling and splitting, this is, whereas the ppm is the big field caused by the electron-rich or magnetic-rich environments, there's also the really tiny impact. So these H's themselves, again, can have a spin of some sort. Clockwise or counterclockwise, we'll call it up or down. So do you smell yourself or do you smell your neighbor? Weird question, but valid one. So if you're sitting, you smell your neighbor. Sad but true, which means you don't care that it's 3 hydrogens, what it's going to do itself, it's what it's going to affect. So you only smell one neighbor over. So B can smell C in the carbonyl carbon. C can only smell B, A can only smell the carbonyl carbon. So the number of neighbors plus 1. So for A, how many neighbors? So here's my CH3 group, 1 over, 0 neighbors, 0 plus 1, okay? For B, how many neighbors? 0 on one side, 3 on the other. Perfect, 3 neighbors plus 1 for the number of possibilities. And finally, this neighbor, or this one, excuse me, C, move over 2 neighbors. So 2 plus 1, perfect, okay? So the impact of the negative of the H's, the very tiny neighboring nuclei, only small impact. But the thing is, because it's randomly distributed, they can be up or down, could be all 3 up, could be 2 up and 1 down, 2 down and 1 up, or all of them down. So that's where the n plus 1, the number of H's, they can just be up or down. There's 4 total possible combinations. 3 up would add a lot, 2 up and a down would add a little, 2 down and up would take away a little, 3 down would get rid of a little. So I'm going to be more interested in that relationship. Okay, Pascal's triangle did this yesterday, and again, it's binomial expansion, it's Hardy-Weinberg, it's anything probability based. But if I have a singlet, it's just 1. And how many remember how to do Pascal's triangle? The ones go down the side, in the middle, 1 plus 1 equals 2, 1 plus 2 equals 3, 2 plus 1 equals 3, 1 plus 3, 4, 3 plus 3, 6. So these are the exponents if you do binomial expansion, x plus y squared, x plus y, I'm sorry, x plus y squared, x plus y to the third, x plus y to the fourth, and so forth. But what this basically means is this group, you already told me, there's 0 neighbors, so 0 plus 1, it's a singlet. B, there's 3 neighbors, so 3 plus 1, quartet. And then, so this just turned into a quartet. And then C, 2 plus 1, triplet. So this turns into a triplet. So let me just figure out what a triplet means and what a quartet means. So is there 1, 2, 3, 4 local peaks within that overall signal? And the area is 1 to 3 to 3 to 1, not the height, but the area. Okay. This is a singlet, and this is a triplet, 1 to 1 ratio. Okay, so I'm happy with that. So I've now taken care of the shift value, the big magnetic field, and then the coupling, the splitting, which is kind of ironic because coupling seems like come together and splitting is when they break up, but I don't know why they use both terms. So you're coupled to your neighbor, which causes a splitting of your signal. Okay, what am I missing then? I found the major magnetic field impact in the TPM. I found the minor magnetic impact of the neighboring H's. What's the last part of it that I'm missing? So I've done shift value, the overall PPM, the coupling, singlet, doublet, triplet, quartet, etc. What's a third thing associated with NMR? Intensity of the curve, area of the curve. So is it quantitative? If I have 3 H's here, 2 H's here, and 3 H's here, does that mean the total area should be a ratio of 3 to 2 to 3? So this should only be an area of 2. It should be an area of 3 and an area of 3. Is it correct? Is this an area of 2 to 3 to 3? Nope, so I need to scale it down. That's the last piece of the puzzle. So one more thing to add to it. So free to click. One more thing to toss at it. So I need to scale this down. This has become a ratio of 2. So this has to get smaller. So area under the curve is simply the quantitative relative amount of how many H's you have. So an area of 2, an area of 3, and an area of 3. So this has a scale down, this has a scale down. Excuse me, leave this one the same. So with 2 H's, make that smaller. 3 H's, make that smaller. So the total area under here is 2 to 3 to 3. So does that seem okay? There's 3 parts to it. So let me ask you this. What is the most important part? The signal, the splitting, or the area? So get a signal vote. Signal vote. Signal vote, area vote. So let me ask you a different question. What is the most important thing in Sudoku? The columns, the rows, or the boxes? Which is the most important useful piece of information when doing a Sudoku? The columns, the rows, or the boxes? Got a boxes vote? And do you guys actually do Sudokus? Is this a valid example? So column. Yeah, okay. So yeah, it's not a very good example, so sorry about that. But basically, the answer is whatever they give you. So, favorite student? So for everybody who's jealous, they are really cool. But do you agree? If they give you a bunch of columns, you do columns. Give you a bunch of rows, you give you rows, or do rows. They give you a bunch of boxes, do boxes. Do you agree? You respond to what they give you. The most important thing in NMR is the one that they give you the most of. If they give you a bunch of PPM values, shift is most important. If they give you the splitting pattern, coupling is most important. If they give you the area is most important. So you need to go with an open mind to say, what have they actually given me? So I'm going to take this and I want to apply it to a couple examples, questions followed by specific examples. So for this one, I hope this is pretty straightforward, but what shape is that peak? And I kid you not, this is actually highly inspired by a previous AAMC experience. So what is this one? Quartet. Perfect. 1, 2, 3, 4. So I'll let the machine do it. And freebie is a really harsh word, and I should never use it, but still going to use it. So it's a quartet, 4 apexes. What is a ratio? Perfect. If you happen to know x cubed plus 3x squared y plus 3xy squared plus y cubed, you would know binomial expansion has a ratio of 1 to 3 to 3 to 1, 1, 3, 3, 1. Same as probability, same as anything that you're in a sort of expansion of. Okay, I'm going to get rid of the binomial expansion, Pascal's triangle, just say that I sort of have this program. Okay, so let's apply it as you learned it in school, and then we'll go ahead and move on. So I'm doing it backwards. I have a couple things. First and foremost, units of unsaturation. What the heck is a unit of unsaturation, degree of unsaturation, hydrogen deficiency, whatever it was called when we were in school? What does that tell me? Does it tell me anything? Double bonds and or rings, exactly. So how many bonds does carbon make again? 4, and how many do you need? How many bonds do you have to keep a chain going? If I want to be part of a giant chain of people, how many hands do I need to put in to keep the chain going? 2. So for every carbon plus 2, every hydrogen minus 1, every oxygen, take it as is because it makes 2 bonds. There's always 2 ends to every chain. So I remember the equation not by memorizing the equation, but by instead saying, what does each atom do? So for every carbon, I multiply by 2. For every hydrogen, for every oxygen, I ignore it. And for the end of the chain, I 2. How many hands do you need to make a link? How many electrons do you need to make a bond? 2. So the number of extra electrons divided by 2 electrons per bond equals 1. So if I told you this was either a ring or some sort of carbonyl, would you believe me? And those, I mean, there are a couple different possibilities, but would you agree, any way you cut it, C4H8 would be 2, 4, 6, 8 H's, 4 carbons and an O, or 1, 2, 3, 4 carbons with 3, 4, 5, 6, 7, 8 H's and an O, or 1, 2, 3, 4 carbons with 3, 5, 7, 8 H's. So it can be any of those based on the formula. Okay, so is it okay if I erase the possible structures? I need the room, basically. So I'm going to get rid of my potential structures. I'm going to leave the units of saturation because that's helpful to me. And I want you to walk me through this. Tell me first and foremost, would you buy into the fact it's a 2 to 3 to 3 ratio? Yep, exactly. Okay, can I quote you on this? Okay, so somebody typed in there, hey jerk, that's what they called me. You blew it. You totally got this one wrong because don't you understand it can't be a ring because there's too many unique H's? Okay, I might have added embellished a little bit. I'm so sorry. You're so sweet and that's just so wrong to do. But anyway, but yeah, the comment was it can't be a ring because there are 3 different hydrogens. And what would happen for a ring? Same. There would only be 2 types. So are you automatically starting to do it in a more process elimination approach, answer choice backwards approach? This is the one advantage you may have over everybody because if you've never seen it before, you're going to learn it in a multiple choice format. For most of us, we learned it in school. We learned how to take the formula and all this information and try to build a structure, which is time inconvenient. I'm going to do it this way, just like the icebox. I'm doing it the school way first, and you're going to figure out the shortcuts to take. So how many agree I have a CH2, a CH3, and a CH3 from the integration? They gave me that. So this is a 2H quartet, which means area is 2H, so it is a CH2 group. Quartet means what? Tells me what it is or what it's next to, what it is or what it's smelling. What it's smelling its neighbor. 1, 2, 3, 4 peaks. 4 minus 1 means it's next to a CH3. And the shift, pretty close to electron which group because it's the furthest downfield. It's next to a carbonyl. What is this one? Well, 3H, so it is a CH3. Singlet means it smells nothing. And then high shift, so again, next to a carbonyl. And then finally, this one's a triplet. It is a CH3. It's a triplet, so it is next to a CH2. And it's a low shift value, which means it's the furthest from the electron-rich environment. If you are really good and you've seen these over the years, yes. but I have yet to meet anybody who, even PhDs that have done this their whole life, that can look at it. You have to get it integrated. So the machine spits out the data of what area is as it goes across. So they have to spit it out to you. If they don't spit it out to you, then it's an educated guess. The only thing I would know is 3 signals. They couldn't be equal. It couldn't be 2 2/3, 2 2/3, 2 2/3, because you can have unequal amounts. And so I could take an educated guess it's a 2 3 3, because you can't have 4, otherwise it'd be a methyl group. But beyond that, you'd have to be given. Okay, I'm going to get rid of the units in saturation because it's now officially in the way. I'm going to tell you, if I have a CH2 next to a CH3 and a CH3 next to a CH2, what are the odds this CH2 and this CH3 are coupled? And that this CH3 is sort of by itself. So I've taken care of 3 carbons. I've taken care of all 8 H's. There's still a C and an O to take care of. So here's my C and my O. I have to have a C in here somewhere. C can make 4 bonds. O can make 2. So connect the dots. And sure enough, hey, Jonathan, could you let somebody in? You know what? I have learned a trick that I can get it to work. Thank you, sir. Appreciate it. So this is the way when you took OChem, you looked at the spectra and had to deduce. The MCAT is fill in the blank or multiple choice. I can't remember. Multiple choice, which means, is NMR better to be done from information forward to get a structure, or is it easier to work from the structures backwards and eliminate ones that don't fit? Structure backwards. You have to go from the 4 choices backwards to make this worthwhile. So exactly what Brooke said, or somebody said, I forget who it was, but somebody had mentioned that you can't be that because it's too unique. Things are too different. Okay. For this one, 6 H's, they're all roughly the same. So I'm going to say 2H, 2H, 2H. Triplet, and quintet, meaning what are the odds it's a CH2 next to a CH2 in the middle, next to a CH2. So does this seem reasonable? And how many units on saturation? I'll let you guys do this all by yourself. What do you do for carbons? Two extra bonds. I subtract H's. I do nothing for oxygen. I add 2 for the end of the chain. There's 2 electrons per bond. 8 minus 6 plus 2 is 10 divided, or 10 minus 2. Time out. 8 minus 6 is 2 plus 2 more is 4 divided by 2. 2. Perfect. Okay, so 2 units in saturation in this case, which means could be 2 pi bonds, could be a ring and a pi bond, 2 rings. With so few heteroatoms and so few carbons, probably not 2 rings, but we'll see how it works out. So I know the CH2 is connected to CH2 connected to CH2 because they're all linked in a certain way. So that takes care of all the H's and 3 of the carbons. So I still have a C and 2 O's. So I'm going to put a C on one end, O on the other, and probably my carbonyl. What are the odds it goes around something like that? Meaning, would this structure explain it? So would this be A, B, and C? Would that fit? I think so. 3 CH2s, one next to an O, directly next to an O, so it's even further downfield, one next to a carbonyl carbon with an O, and then one far away from everything. But again, your goal, look at this other way. So this is how I would do it in school. Quintet means 5, so 5 minus 1 is 4. Yeah, so for unison saturation, again, consider the following. How many bonds does it make, whatever it is, whatever the atom is, minus 2, because that's what you need bare minimum to keep the chain going. So carbon makes 4 bonds total, 2 minimum. So for every carbon, there's 2 extra bonds or bonding electrons available. Hydrogen makes 1, we need 2, so 1 minus 2 means minus 1 for every H. O, oxygens make 2 bonds, so I completely ignore the oxygen, 0, because 2 minus 2 is 0, and then 2 for the end of the chain. So the total number of extra bonding electrons are 4 times 2, 8, minus 6, minus 0 plus 2 for 4 in the numerator. 4 electrons divided by 4, or 2 electrons per bond, gives me 4 over 2, which is 2 extra bonds. Oh, nope. So what would you do for nitrogen? +1 for nitrogen. Why? Absolutely right. Marissa, why do you say +1 for nitrogen? Okay. How many bonds does it make? Nitrogen makes 3 bonds. Nitrogen. So nitrogen makes 3. 3 minus 2, you need 2 to keep the chain going. So does it make 1 beyond the minimum of 2? We need to keep the bond going, keep the chain going. It needs an H, if you will, exactly. To make the 2 bonds of carbon, but it needs an extra H. So nitrogen would be a +1. Halogens would be a -1 because they make 1 bond. So it's basically everything relative to 2. 2 keeps the chain going. So you base it on how many bonds it makes minus 2. That's how to pick the numbers, what you do with all these. Okay, so feeling pretty good. So I want you to do this in a multiple choice format. This is the same thing. I want to go back and forth real quick. Sorry for this. But is this a 2H triplet around 3.5, slightly higher than 3.5? Is this a 2H triplet slightly above 2? And is this a 2H quintet somewhere around 1? Picture drawn for you. Is this question? Oh, I did myself in. Sorry, so sorry. Sorry, I have to see this whole picture come in again because I don't know how to do computer things. Is this the same thing? Is this a triplet? High 3s, a triplet, low 2s, and a quintet around 1. And then of equal integration, meaning are they all 1, 1, 1 or 2, 2, 2 or whatever it is? Is this the same thing, but words instead of a picture? And instead of here's the information, what is the structure without multiple choice, is this working the other way around? Equal integration means 2 to 2 to 2, 3 to 3 to 3 means the area under the curve. So when you integrate, remember in calculus, integration is summing up the area under a curve. So it means the area under the first peak equals area under the second peak equals area under the third peak, and so on and so forth. It means all of them are equal. They're all either 1H, 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 2H, 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 3H, 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 7H, 7H, 7H. They're all the same. Same number of H's, exactly. Perfect. And would you agree, it's not a difficult concept, it's learning the freaking language associated with it. And that comes with repetition. You're learning several foreign languages. So what is most important? The shift values, the integration, the number of equal hydrogens, coupling, all of it helps. So let's pick one that's important. Whatever they give you. They give me a bunch of shift values, so that might be good, but they give me a bunch of shapes, that might be good, but they also give me integration. So I'm gonna go with integration. Basically, they're all equal. Yes, 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 yes. Everybody see what Michaela has written? This cannot be. we don't have a 3H singlet. Okay, so you mean tell me because I saw no singlet, I saw nothing at 3H, I don't have a 3, 1, 1, 1, I have a 3 or a 2, 2, 2. So what other one do you want to get rid of? Is there something else that also would have an isolated singlet that wouldn't work? Okay. Anything else has an isolated singlet that wouldn't work? Only one answer left. Is multiple choice NMR easier than real NMR when you took it in OChem? Far easier. Let's make sure this works out. Let me just double check. Is this an A, B, C? Are they different by symmetry? Is this one next to an O, so this be 3.7? This next to a carbonyl, so this be 2.2 or so? This is around 1 because it's away from everything. Those are the peaks I get. This one's a triplet because it's next to 2 H's, it smells 2. This is a triplet because next to 2 H's smells 2. This one's a quintet because it smells 2 and 2 for 4. 4 plus 1 is 5. Does this fit? And the fact that I just did it on the previous example, but the beautiful thing, again, is it easier to do it backwards from answer choices to information rather than information of that? So why isn't it? Oh, Michaela, you were the one who gave us this one. So I was actually going to ask you why it isn't. So you said this one can't be true. Why? We don't show a 3H singlet. Nothing is a singlet in this. Unequal hydrogens. So same thing here. This would be unequal hydrogen because this would be A, and B. So you have 4, 1, 2 of the other, and a singlet. Oh, if typing is no big deal.
I guess the reason why I'm confused is like because when I'm saying unequal hydrogens, that's because so for example, like on D, there's 3 hydrogens, right? But then for B and C, like I was just counting it as all of like A, B, and C all have 2 hydrogens each. So I thought that
so
meant
on B
that
that's true, but let's go back to C. Isn't C 4 H's and 2 H's? Because aren't these the same?
Oh yeah. Wait, 1, 2. Sorry, could you explain that part again?
Yeah, so if I drew a line like this by symmetry, A is equal to A. So 1, 2, 3, 4 H's are equal. Here, there's just 2 H's. So they wouldn't be equal. So for your reasoning, this one had an unequal one, this had an unequal one.
Gotcha. So it's not specifically like the number of hydrogens present, it's
Equivalent hydrogens.
okay. Okay,
C would have just 2 peaks, exactly. How many peaks would B have? 2 signals, exactly, is the correct term. But did you know what you were saying? Yeah, and that's the thing. I am far less anal about the language because it's more important, can you read their language, not can you speak the language of chemistry. And so if you're not a perfectly eloquent PhD level speaker in biology, chemistry, physics, cars, psych, soc, you're fine. This one, I'm going to go on the notion you would actually have 4 because trans and cis, the one that's cis to the O is going to be different than the one that's trans to the O. They'd be really, really close, but you'd actually get 1, 2, 3, 4 signals. This is really anal, and this is probably a little bit above me on what they would do, but because they can't rotate around a pi bond, one is always cis, one is always trans, so they will feel different magnetic fields. Whereas this one, these 3 are all free to rotate, so we consider them all equal. This is planar, above and below, so we consider them equal. What is a hat drawing? I have no idea. I'm unfamiliar with this.
In the video that one of the videos that people posted on Discord, the lady explains how you can tell if a peak is part of, like, if it's together, if they're really close together, how you can tell if they're part of one signal or two. And basically you draw like the 3 points of a triangle over the top of it. And if you can connect all the tops, then they're a part of the same signal. And if you can't, then they're not part of the same signal. Does that make sense?
Right. No, that's good. If you can circle them all and connect them all, that makes sense. This is a really weird case. And I don't know if it's beyond or within the scope of the MCAT, other than because you can't rotate around a pi bond, they can't become equal. That's what it comes down to. And a lot of times the videos are solid because they give you nice, wonderful things that work 99% of the time. And if I happen to be throwing some weird one that's an exception, note that, yeah, not everything you're taught is perfect, but it's good enough for the MCAT. And I have no doubt it was a solid video, other than I just screwed with you. So. Oh, the video would tell you separate peaks for these two. Oh, then yeah, if it would show you that they're different, then my hat's off. No relation to the hat that they have. Okay, pounding through. I went with the everything's a singlet. B is a singlet, so it's out. C is two signals, one of which is singlet, it's out. And then B, singlet, and unequal number. So A is your only choice. I'm going to throw a couple more, and then we'll get into what everybody submitted. Nomenclature. If they give you nomenclature and it's NMR, should you draw it out? Yes, got to see your symmetry. For OChem, drawing it out. So I've been asked multiple times, is there nomenclature on the MCAT? I'm going to say yes, because you have to know your nomenclature to draw it out. But no, they're not going to give you, here's a structure, what is its name? But more, they might give you things in terms of names, structures. They're usually pretty good about giving you structures, but I'm going to give you the name in this case. So is it, let's see, 3-pentanone. So is it 1, 2, 3, 4, 5 carbons long? Carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. This is on carbon 3, so pent, 5 carbons, 3 one with a methyl on 2. So are these H's similar or different? These are the same. They're each 2 carbons away from the carbonyl. So these get an A. It's going to be 6 H's total. Why is it a low ppm? So that question popped up and I ignored it previously, so let me address it on this one. So why am I saying it's a low ppm? Because are they close to the carbonyl O or a little bit further away? Further away, so I'm going to say a low ppm. So low is around 1-ish. So would you agree a 6H doublet, because there's 1H on the neighbor, so you only smell 1, 1 plus 1 would be 2. So would you agree these would make a 6H doublet, low ppm because it's far away? Everything's relative. So it is closer than way down here, but that's not part of the molecule. So let me say, instead of close or far, is it the closest or farthest from the carbonyl of everything we're looking at? You agree it's the farthest away from the carbonyl. So being farthest away, it's going to be less affected. So it's going to be farthest upfield, farthest in low numbers. Okay, what about this H? I'm going to call it B. This B, do you agree? For B, it's 1H. Why is it a septet? Yeah, so these are about the same as over here, which means notice how the ppms are really, really close. The only difference that CH3 here affects it ever so slightly. That brings it up. And then same thing, this bulkier group here makes B a little bit more subjected to density than this one. So notice how these are really close to 1, 1, and 1. These are really close to about 2.25. Minor differences. But people write PhDs on that minor difference. So I'm not gonna make it overzealous. But then, yeah, as Monica said, this one has 3 plus 3, 6 neighbors, 6 plus 1, 7. How do you say 7 in NMR language? Sept, like September, the 7th month in the calendar, if you have a really screwed up calendar that's based on the sun signs. So hopefully this seems okay. And by the way, anybody ever get bothered by that Sept, Oct, Nov, and Des are 7, 8, 9, and 10, but the 9th, 10th, 11th, and 12th calendar months? Or how many just don't notice that thing and generally are a happy person? Anyway, food for thought. Okay, so B looks good. What about these? I'm going to jump to this end. These are all equal. I've screwed with you by drawing all 3 separate, but do you agree they're all coming off the same carbon? So CH3 group, all are D, 3 H's. Why is it a triplet? Two neighbors, you smell 2 plus 1, so triplet. Low ppm because it's the farthest away. And then finally, this group right here, what would you get for this one? 2 H's, high ppm because it's close. But you read there's 3 neighbors, 3 plus 1 would make it a quartet, not a triplet. They have done things like this. Is this just a test of do you know how to read an NMR or predict an NMR outcome? So the different types of questions. How many H's by symmetry? The simplest of all the questions they ask. So something you might say is, after you carry out this reaction, would you see an increase in the NMR signals by 1, by 2, a decrease by 1, decrease by 2? You have to count number of H's in the original compound and final compound, make that decision. One type of question. Number 2, how would you distinguish one thing from another, like the previous question? So given 4 choices, which one would fit the NMR spectra? And then there's also this one. Can you name those signals? So different ways they can ask the same thing, but it's pretty straightforward, pretty good. So finally, one last type of question. And that is, how do you distinguish one thing from another? Or how do you distinguish? So the question is, and I want anybody to answer this, how or does electron density interfere with the NMR so it's harder to get those signals? Okay, so based on the lecture you just had with Coy, what causes a magnetic field? So weird sort of question, but it'll apply, I hope. Moving charges, that's one thing, and in this case, spinning charges. So spinning charges can cause it, moving charges can cause it. So nuclei are spinning, that's why H's have a magnetic field, but electrons are moving around, they're constantly in motion. So electrons in motion create a really strong magnetic field, and that's why oxygen atoms, or heteroatoms in general, halogens, nitrogen, oxygen, do they mess with the NMR? Do the electrons, the lone pairs on those atoms, create magnetic fields which create, I guess, higher ppm values, further downfield shifts for things that are near those atoms? So long story short, yes, the electron density, because electrons are moving around, they're spinning, especially when you put electrons in magnetic field will impact how they spin, and you'll get an additive magnetic field. So basically, when I say close to electrons, I'm really saying close to the magnetic field generated by the moving electrons. Okay, what is butte now? Butanol is how many carbons? 4. And what functional group? Perfect. Ooh, Jonathan, can you do your dirty work? Thank you, sir. Aldehyde? I know, it might make you feel really stressed out. Open the door, answer the question, get to work, get anything recorded. So there's a lot of pressure on you. 4 carbons, 1, 2, 3, 4, check. Aldehyde function group, check. Let's see what matters. Would you get a 9 to 10? You have an H really, really close to lone pairs. And this unfortunately ends up being memorization, but these are H's on a carbon next to a carbon next to an O. This is an H on a carbon directly bonded to the O. So it ends up, because of all the electron density there, the magnetic field is really strong in this H. This one ends up being 9 to 10. Just one of those random facts. So aldehyde protons are in the 9 to 10 range. Carboxylic acids around 10 to 12. And so in that massive pile of information you got on Sunday, there was a list of shift values. I don't think you should memorize a ton, but you should know a handful. You should know that alkanes come around 1-ish. Alpha protons, and alpha because it's so common in OChem, around 2 to 2.5. Alkoxy are around 3.5-ish. Benzene, around 7. Aldehydes, around 9 to 10. Carboxylic acids, around 10 to 12. If you memorize this whole thing, you will never need it in your life. Okay, I don't know if you can hear me, but no problem. I'll see you in a second. So shoot, sorry. I clicked on too many things. I was trying to move something. So, okay. So back to this one then. Will I get 4 signals in a 1, 2, 2, 3 ratio? Yeah, I mean, is that a good way to look at it? The way Brooke just said, how many can look at that? The more oxygen you're near, the more excited it gets, the more oxygen you're near. I get really excited around those magnetic fields of oxygens. This one's a little bit weird, but the electrons can move around in a ring. When you have things move around a ring, create a magnetic field. That's why this is a weird anomaly. But right on an O and close to an O, that's big time. Close to an O, kind of big time. Kind of close to an O, not as much, a little bit further away, and then no O. And so hopefully those seem reasonable. And at this point, how many are just going to memorize everything you can within reason? And then just live with it. Kind of what you have to do. Okay. All right, so 4 signals, that sounds reasonable. I'm good on that one. Will you have a signal between 2 to 2.5? Do you have an H on an alpha carbon? Here's a carbonyl, here's an alpha carbon. So do we have an alpha one? Sure. What the heck is a broad singlet? What would cause that? An OH, exactly. So do we have any OHs? Do we have any hydrogen bonded species? So not a singlet would be isolated, but it ends up broad means H bonding. Don't have anything that H bond. H on a carbon 1 H bond, so no H bonding, no broad singlet on this one. So no isolated proton, no broadening. So broad meaning the peak would look something like this. So just indistinguishable, just a mess. Because of hydrogen bonding, you get a drowned out signal, so it gets spread out. Just it's still the area of 1, it just flattened. So instead of seeing a sharp signal like that, turns into just sort of a rolling blob like that. Same area under the curve. just more flattened out. Can't see any peaks, ugliness. So alcohols and carboxylic acids are just rolls in the baseline. They're one of those you just have to kind of know it's there. You can easily miss that one. But that's why I go to doctor school instead of OChem grad school, and you'll never have to worry about missing that. Then you get to miss other things like diagnostic signals and so forth. Okay. Feeling pretty good about this. So I hope this NMR summary is worthwhile or summarized. This is what somebody would want. So I know I spent an awful lot of time, and I think one of the people who asked for it actually didn't show. But oh, you're very welcome. So this kind of thing that it sort of hopefully solidifies the type of questions they ask. And again, the big thing you have to be getting from your review. And if we're dropping the ball on it, you're picking it up in other places, obviously, because you're kicking ass. How do you apply it to questions? That's ultimately what you're always going to ask yourself. Okay, so plowing into the questions that were submitted. For this one, I'm basically going to blow through this one kind of quickly because this is one of those, you had to get it from a passage type of thing. But when we react with deuterobenzene, so deuterobenzene is this compound, one deuterium with H's as such. The passage tells us that if we had palladium metal with H2, it adds H's. If we had palladium with D2, it adds D2s. And so if I draw this after reaction, I'm going to end up with H in deuterium, H deuterium, H deuterium. So it tells us in the passages, or in the passage, excuse me, that whatever you're adding comes out in front. So the key thing is the H's are back, 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 and back. So if I were to draw a chair conformation, cool trick to drawing chairs again. If the point is down, axial's down. If the point is up, axial's up. Point is down, axial's down. Point is up, axial's up. Point down, axial down. Point up, axial up. I can also draw it like this. Up, down, down, up, down. Okay. So if I'm considering the H's could be down, 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 which would mean down would be equatorial, down would be equatorial. So they could be 3 ax and 2 equatorial. Or they could be potentially H, 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 and H. So I could have 3 ek and 2 ax. Would you agree with that? I mean, does that make sense that if they're all down, they alternate axial, equatorial, axial, equatorial, axial, equatorial? So if all of them are down, every other one, so I could start axial. So I could start axial, ek, axial, ek, axial, or I could start equatorial, axial, equatorial, axial, equatorial. So based on that, gone and gone. You had to get this from the passage, but which is larger, H or deuterium? Okay, D is heavier, but this is what's kind of weird what this passage was getting at. So how many heard that if you gave somebody D2O, made them drink deuterium oxide instead of H2O, you could kill them? Have you ever been told that D2O is actually toxic? If you fill the person's body with deuterated water instead of hydrogen-based water, they would die. What the blank? Why would that work that way? It's the following. Kind of a cool OChem little notion, but do bonds stretch, bend? Do they move around? Sure. So if I have this situation, this is the take-home message from a bio standpoint. If it's light as opposed to heavier, which one moves around more easily, light or heavy? Lighter moves around more. So this one can stretch further, this one can stretch shorter. So the average bond length here is actually longer because it can stretch here and here than this one. So 1H is actually bigger than 2H. So 1H can hydrogen bond. For instance, do we ever have proteins that have bridging waters? Is that something you ever heard of? Is protein that has a bridging water connecting one, let's say, side chain to another? Is that something that has popped up in your bio travels? So the longer it is, the easier it can bridge. If you put in D2O, you can't bridge your enzymes. You can't get coordinated things, let's say, in a transition state. And an enzyme substrate complex won't have the water binding because it's too short. So it ends up, your biological functions actually shut down because these bonds are too short. Long story turned into a shorter story for this one. Which one do you want? The longer bonds equatorial or longer bonds axial? Longer bonds equatorial, exactly. So you want axial D's, you want equatorial H's. So in this case then, if I have 3 axial H's and 2 equatorial H's, that's bad. If I have 3 axial H's and 3 equatorial H's and 2 axials, that's my best answer. Long-winded thing, and I'm actually gonna probably blow off going much further into this because this is one of those passages I kind of regret keeping in the book. This is something they threw years ago on this deuterium isotope effect, and they actually mentioned the fact that enzyme kinetics, your enzyme, your binding affinity and the turnover rate decrease when you replace H2O with D2O, and they mentioned something about this. That's been so many years since it was on there that I think it's safe to say probably can ignore any chance of being recycled. So I'm simply going to say in this case that you get the important thing. Longer wants to be equatorial. That's absolutely right. So longer is equatorial. So you want more H's equatorial than axial. So your what is the ratio of equatorial to axial? Most of will share confirmation. You're 3-2. It was a little hectic. I'm going to blow it off to get to more important pastures. This one is more important. So what structure represents the most stable form of cis? What is cis? Cis is opposite side or same side? If you're on the same side, you're cis. Okay, and you're Z when it comes to a double bond. So same side cis, perfect. So can I get rid of this one because they are trans? Can I get rid of this one because they're trans? Quick and easy way, draw a line. Actually, let me choose a different color. Draw a line from the two. They are on opposite side or same side of that line. Opposite. If they're on the same side of the line, they're cis. On the same side of that line, they're cis. Cool trick for chairs. So if this was down and up, they'd be trans. They're both up cis, they're both down cis. How many have seen that trick before with a line for chairs? No, nice, easy, quick way to do it. Helpful. So it's got to be cis. So I can get rid of A and B. And now the question is, which one do you want? Michaela, I think you were a resident expert on this one. Longer equatorial, perfect. So which one do you vote for? How do you vote? D is in, damn, that thing's big. Let's put it equatorial. Perfect. So does this one seem okay? Was the hardest part deciding which was more stable or cis? There were two parts of the question. This part's kind of a pain in the butt. No doubt about it. Recognizing cis and trans, up, up, down, down. So which is more stable? More stable is the one with the bulkier group on the equator as opposed to axial. Because they're cis, it ends up at 1 and 4, one has to be axial, one has to be equatorial when they flip. So the problem is, if it's really big, can it run into the other axial groups? So is there all sorts of steric hindrance noise right there? Whereas here, is there a little more room to fit in? So axial things bump heads with each other. So you want to put the biggest things out to the side and put your smallest things to head bump each other. If that seems okay. So does this steric hindrance make sense that this is what you're trying to avoid? So you push it out here. Leading to Michaela's conclusion, and that is big things get pushed to equatorial. The bigger you are, the more you want to be on the equator, not bumping heads with stuff on the axis. Okay, onward I march. Which of the following sets of 1H NMR signals would be associated with compound 3? Oh, you guys own this. I'm not gonna say anything. You guys are gonna solve this for me. I'm gonna be lazy. What signal do I get based on that H? (9.7). And this is where it gets messed up. So instincts would say singlet because it looks like it's isolated by a carbonyl. But I actually want you to draw this out in a weird sort of way. Let's say something like that. Do I have an H on this carbon next to a carbon that has H's? An aldehyde is not necessarily a singlet. It doesn't couple well, but it is still, if you agree, an H on this carbon, its neighbor has 2. So this is actually going to be a triplet. The betrayal, exactly. It just, damn, because we are so used to thinking of carbonyls like ketones that break it into 2 R groups, but it actually is still a neighbor. So I can get rid of this one because there's no 9.7, 9.7, 9.7, 9.7. We're good on that. The fact that it's a triplet sounds good, so that's out. So how do I figure out the rest of the structure? Is this a singlet? One less standing. Process elimination NMR. How many have gotten to the point where you can actually see this getting a little bit easier with each example we do? And what's so cool, Brooke, sorry to single you out, but mostly because you voted yes. 2 days ago, did you not have any clue what this stuff was? Which means you are unbelievably smart and you pick it up fast. You just got to learn the language. And this is a message I want to send to everybody. Sometimes it's a matter of you've forgotten something to reacquaint. Other times you have to learn everything from scratch, but there's nothing on this test you cannot figure out. Nothing you can't solve. You just have to just build up that speed more than anything. Speed and confidence, but you know everything. And so it's been pretty cool to watch you pick this up. Now, you worked your ass off to get it, I'm assuming, by stressing out, going over things, listening here, watching a video, applying it. So it hasn't come easy, but it's come. So are you to the point you could teach it? Yeah, you can. That's a few hours away. Okay. Which of all molecules would have the greatest lambda max in UV? What the heck is UV? So UV pretty much in OCHEM, we use it for one thing and one thing only, ultraviolet light. So let me go in a different direction. When I have a colored species, is it UV active or visible active? Visible active, perfect. How many learned conjugation equals color? When I have lots of conjugation, I get color. So it ends up, lack of conjugation will have a pi star transition of around 180 nanometers or so. Notice on the or so. If it's a carbonyl, because we have lone pairs, we have non-bonding electrons can be involved now, the transition is going to be around 245 nanometers. Okay, sounds reasonable. If we have conjugation, it ends up, it's around 225 nanometers. We have conjugation here, it ends up, it's around 290 or so. So it goes up, I'm going to say around 45. This one is actually a little bit more than 45. But we end up, I'm ignoring some of the other R groups, but this is a good educated guess. Now you may learn this is more like 260, 270, 280, depends on the R groups, by all means. You may learn this goes up by 50 or 55, depends on the R groups, by all means. So this is a general rule of thumb. But generally, the greatest lambda max, is that going to be conjugation or no conjugation? So just numerically looking, no matter, even though I may not be exact on the numbers, you agree as I add in conjugation, is the lambda max getting larger? Is it going from 180 to 225, 270, and so forth? Sure, lambda max goes up with conjugation. And number two, which has a greater lambda max, an alkene or a carbonyl? Perfect, with carbonyl. So let's see what I get. Own or set. Own is going to win. And then the second part, which one of these has conjugation? Yes, the lone pairs can resonate. And actually, they can't resonate in the system, but it really comes down to this, and I'm kind of dodging, and I shouldn't. I should be more forthright. Lone pairs are referred to as non-bonding electrons. So your transition ends up being from non-bonding to pi. So it ends up being a smaller gap. Do not say sorry. That's a good, valid question, because I'm throwing information out there and I'm just throwing it out without any substance to it. So it's an excellent, fair question. I'm just kind of just trying to blow you guys off and hope you don't notice. And you busted me. So it's solid. But it's just because you can have excitation from anything that has electrons, anything that doesn't. And so because you have lone pairs, they can get excited up. Weird theory, but it explains things, so we're good with it. So tell me, back to this, carbonyls beat non-carbonyls, and then which one has conjugation, the anion or enone? En. Perfect. I didn't draw the structures out, mostly because I wanted to really focus on the UV part. But the moral to the story, UV is just not that important. So we're looking for the greatest lambda. So the greatest lambda is the one that has conjugation. If you're looking for the smallest lambda, then you want no conjugation and no carbonyl. And so in this case, specifically, we're asking for which one has the greatest lambda max, which means the greatest numerical value. So lambda max goes up with conjugation and with a carbonyl. Perfect. So hopefully that seems okay. So in summary, why would I ever care about UV vis? It's honestly kind of useless. It's a little extra aside they might toss in there. It tells me one of two things: carbon-carbon double bond, carbon-oxygen double bond, or carbon-nitrogen, some sort of double bond. and conjugation. Tells me there's a double bond minimally and tells me the conjugation if I know how to look at it. The only time we really use it, and I'm going to go off on a different tangent, does this look at all familiar? Does this equation look vaguely familiar? Beer's law. The absorbance is proportional to the concentration. So I'm going to mess with you because, again, this is how I get my job satisfaction. But could I use Beer's law on an alkane or an alkene? Ene. Why do you say that, Marissa? Totally got it right. Why do you say an alkene, not an alkane? Alkenes are UV active. They have an invisible or UV somewhere in the 200, 800 range that Beer's law is working. Alkanes do absorb UV, but they absorb it down in like the 170, 180 range, which is just noise within the world. So everything can absorb UV, but the ones that we actually can monitor are double bonds. Okay, one more question in this realm. Hey, an NMR question, perfect. So help me out. If a compound had an ethyl group on benzene rather than a methyl group, which of the following would you look for? You guys so own this. Okay, so let's see. 2H and 3H, we agree that's what it is. And the shape is based on what it is or what it's next to. So when you change your shape, it's because you smell the person next to you. You coil up, you spread out, you do whatever you're going to do. So this 2H is next to 3. 3 plus 1 would make it a quartet. These three are next to 2. 2 plus 1 would make it a triplet. So I'm looking for a 2H quartet and a 3H triplet. So doublet, triplet is out. 2H quartet, check. 3H triplet, check. D is in, damn. So how many got it but didn't have the confidence to say you got it? Oh, you're welcome. I hope this is one of those things that's kicking in. And that's and the reason I asked that is if you got it right, but you didn't have the confidence, give yourself 5-10 seconds to celebrate. You know it, you just don't believe you know it. Next step is believing. And it's hard. It is so hard to do this. And it's easy for me because I'm not taking the MCAT. I don't have the stress you guys have. It's easy. Oh, believe in yourself. Let's all hug. All that crap. You go through this. And how many agree it's only after enough wins you start believing you can win? Celebrate your wins because Lord knows the books that I've written, books that Dale wrote, the bio book, do we make you lose a lot so that you read answer explanations and learn? I'm writing books that 56 to 67% is doing great. If you're getting 56 to 67%, you're going up to be in that 65, 70 percentile in the MCAT, meaning you're that 127 range, plus or minus a little bit. So getting beat up is par for the course, which is awesome for learning, just horrible emotionally. So you have to start feeling good with every victory. Celebrate every win. Okay. GChem, moving onward and upward. So for this one, what I want to know is what the heck is going on in this? Is this a titration curve drawn in a weird and different way than I'm used to seeing? And this is when I'm going to actually tap into your input, that damn table. Oh, you need a stronger word than damn, but I do agree. So my question to you, for anybody who's taking the MCAT, did they ever take something you know and change it slightly, change the axis on a graph, change the way the information is presented? Were they ever guilty of doing that sort of thing, presenting it in a slightly unfamiliar way? Every time? It sure felt that way to me. I mean, maybe it wasn't every time on mine, but it sure felt a lot of times they were intentionally trying to present things in a way that was unfamiliar, and I had to deduce what was going on. So we normally draw curves, now we see tables. So let me draw a curve and you tell me weak or strong. That curve? Maybe I'll draw it cleaner because I don't know if it came across, but this curve right here. Weak, why is it weak? Has that little cusp, that little lip in the beginning, okay? Strong or weak? Strong, perfect. So if I'm looking at pH, a weak one, pH changes, stays relatively constant, and then changes. Strong one stays relatively constant, then changes rapidly. So tell me about this one. Is it changing or not changing in the beginning? How many degree changing? 2.63 to 3.3 to 3.66. That's a change, but then in the middle degree, it's only changing by about 0.2, 0.2, 0.2. Changes a lot, very little, and a lot. Changes a lot, a little, and a lot. So would you agree A is weak? What about B? Changes a lot or a little in the beginning? This one barely changes in the beginning and then changes drastically. So that one's strong. And finally, the last one, how do we agree? That's changing by 2.4 something. That's changing a lot. Then it stays relatively consistent, then changes a lot. So how many are okay with identifying the titrations in a table form instead of a graph form? And how many are still okay with that? Then I'm going to need help with one other thing. On a strong curve, this point right here, is that this point right here? And this point right here, is that this point here and this point here? How many are okay with my taking what I normally see on curves and identifying in the table? So pH equivalents for a strong acid, which we know it's strong, is 7. That's 50 milliliters. It told me in the passage they're the similarity. Half of 50 is 25. Halfway pH equals pKa. So is that pKa for A and is that pKa for B? C, excuse me. Sorry, my apologies. So how many are okay because you know this? It's just weird. It's I get it. I just don't feel like I get it. And honestly, how many are in that category? The yep, I see it, but shit damn, this is tough. And by the way, when you say two profanities together really fast like that, it's not actually swearing anymore. It's a compound word. I taught my kids this at a young age. Unfortunately, their teachers didn't agree and they got in trouble. Okay. So with this in mind, now time to look at this. Third titration is this one. So again, want to consider a couple things. First off, is this the curve? Oh, yeah, so how did we know? And it isn't that this is what I know, it's this is what I know. So this is pH of 7. So I know that's equivalence point. So the equivalence point happened with 50 milliliters. Here's the little extra piece that I didn't get in this table. I had to get from the question or the passage itself. It said all of the acids have the same molarity. So if they all have the same molarity, they all will take the exact same amount of milliliters to get to equivalence. So if 50 is equivalence for one, then it must also be the equivalence for the other ones based on the same molarity. What is half of 50? 25. So that's the halfway point. 25 milliliters is this and this. I'm so sorry, because yeah, there's nothing on here to know that. You had to get it from the passage. Yep, when it's half molar, half equivalence. Exactly. Yep. So don't stress about typos. If you type one more time to try to correct the typo of a typo, it's just the stupid chat box. So in exchange, you must forgive me for my typos as well, and we're all good. So, and the beautiful thing, you totally get the concept. Screw the typos. Okay, so here's what I know then. Is pH 7 before or after the halfway point? So 7.44 is the halfway point. How many 7 is probably around here or so? How many would be okay that 7 is definitely less? I mean, would you agree with that, that 7 is around here? Okay, so give me a guess at what the numerical value is from the table. So the number around there would be, now, how many milliliters roughly would you guess? So if I was a pH of 7, so got a 12 vote, 13.5 vote, 14 vote. So in that 12 to whatever range, so somewhere between 10 and 15, so somewhere between 11 and, you're actually where you're at, 12 to 14. So can I say like 13 and a half, 14? I'll take the middle number of everything you're saying. Doesn't have to be perfect, has to be close. So it's 14-ish. It's a little less than 14, truth be told. So can I say that this number, a little less than 14? So the reality is the base that has been made. So as I titrate, I convert it into base. This is the acid still left over to go. Can I get the 14 to 36? I should multiply it by molarity, but molarity is the same. So I'm just going to do milliliters. Do you agree it's more acid than base, more acid than conjugate base, because I'm less than the halfway point? So based on that, can I get rid of those two? The conjugate base does not exceed it. The acid exceeds the base. And the question is 36 over, shoot, it's like right in the way. I'm so sorry for that. But how many agree 36 over 14 is greater than 28 over 14, which equals 2, less than 42 over 14, which equals 3? So this number is somewhere between 2 and 3. What's the best answer then? Oh, you already got it. So sorry, I'm behind. Is that a really tough question? And the dead giveaway, it's a really, really tough question, is because do I have a whole bunch of stuff built in to explain this question? I mean, have I done this question so many times that it actually became more prudent to be able to have all the add-ons? Which, what are the odds this ends up being asked every session for the past like 6 or so years since I added this question to the book? This is a really tough question. Why is it in there? So let's see the big picture. What is my goal in leaving this question in here? Because it's an ass kicker. This will not make you feel good, this question. It forces you to, number one, know your things in a different perspective. It messes with you. And it teaches the different aspects of titration that you can recognize side by side. And then is it built in a little bit of Henderson-Hasselbalch? Before halfway point, rich in acid, after rich in base, it tells you the AHA ratio. AHA is 14 to 36, but this is asking for the AHA or HA ratio. This is actually for the ha-ha ratio, so it's kind of messed me up from Henderson. But it's a buffer. It's titration tables, which you have to get from titration curves. This is a really tough question that you grow from. And again, that is my big goal. My hope is that after you do these questions, you learn it well enough that you can apply this to new situations. Ha-ah. But hopefully this seems okay. So free to move on from this one. And as I move on, just out of curiosity, how many feel a little bit vindicated when you realize that, yeah, that was a tough question? And by hearing me confirm that, yeah, it's an ass kicker with this purpose of having you learn a certain things, how many agree that it helps? Oh no, the one person who turned this in and wanted to go over it has disappeared. No, shoot. Do you want me to go through this one anyway? Because this one is going to be fast considering we just did the previous one. So again, let's pick up where we left off. Weak, strong, and weak. So from a strong curve, we know pH is 7 is the equivalence point. So that's that. So half of 50 is 25. So that's pK, and that's pK for the weak ones. So now that you see it, is it actually pretty simple and pretty straightforward? And I apologize, we're definitely going to go past the 6 o'clock time. If that is, I mean, I'm so sorry because I realized you guys just been beaten into the ground by everything. Long day, but hopefully this is okay. So I'm going to skip these two and move them to the next session just because they're not here, and jump to ones that actually people submitted. Is that okay? Oh, you're very welcome. And more importantly, thank you guys for your time. Okay, so 3 GChem and 1 physics to go. So for this particular question, which of the following combinations does not result in a galvanic cell where the half reaction carries an E value greater than 0? Okay, I have no idea what a galvanic cell is, so I need some help. What does galvanic mean? Favorable or unfavorable? E is positive. So E of the reaction is greater than 0. Okay, so what they told me is the following, that my reduction, my oxidation, that my reduction, so some metal 2 plus 2 electrons, and I'm just, I apologize, I picked +2 for no other reason than it just seemed like something to do at the time, going to a metal, that this has an E of a reduction greater than 0. So that's what they told me. So the E naught is greater than 0. And so the oxidation, this is going to be metal prime going to metal prime 2 plus 2 electrons in E oxidation. So overall, when I add them together, E net has to be greater than 0. So can oxidation be a negative number? Sure. This can be a negative number, but large or small magnitude. Ah, perfect. If E reduction is high enough, but small magnitude. Now you got to translate that into the answer choices because this is where I'm screwed over. Absolute values, exactly. So this magnitude has to be greater than this magnitude. So E oxidation can be negative, it can be positive. So this doesn't help me. This does. The only way it won't work if this is too big a magnitude. So if the absolute value of the oxidation is too large, that's a concern. That's a concern. And then this is a concern. and this is a concern. So which one is doubly concerning? Perfect. Yep, exactly. Exactly. You nailed it. So does that one seem okay? Yep, and you nailed it. And I really hope that becomes clear. A lot of times the concept isn't hard. It's like, what the is going on? I didn't fill in the blank. You guys can fill in the blank. But what the blank is going on here, and it's that it's hard because it's a not question. So yeah, what it's basically getting at is in order to be galvanic, it has to be, if they're both positive. So it tells me E red is positive. So let me do it in a totally different direction. Let me say E total, I'm going to do it in yellow, let's say. If E of oxidation is greater than 0 and E of reduction is greater than 0, E total is going to be greater than 0. E total is greater than 0. Does that make sense? That those two are both possible? Because it says it must be galvanic. Okay, so now I have to decide then which of these is the bad situation. If E is negative, it could potentially be that. But if the reduction value, if this is positive 0.5 and this is negative 0.4, the absolute value of 0.5 is greater than absolute value of negative 0.4, 5 is greater than 4, then this number is still going to dominate over this one. So E total is going to be small, but still positive. But in this case, E total, let's say this is the 0.4 and this is the 0.5 now. Positive 0.4 and negative 0.5 would add to an overall negative number. This would be the one that's less than 0. So does it make more sense to do it this way, figuring out what E total is, rather than trying to do it this way? Yep, oxidation can be negative if the magnitude is less for oxidation than reduction. Exactly. So 2 ways to solve it. Looking at this and figuring out the relative magnitude and looking which one matches, or figuring out E total for each one, galvanic, galvanic, not galvanic, galvanic, and pick that one. Which is a better method? Whatever works for you. And hopefully that's, again, give yourself permission to be able to do things multiple ways and figure out which is the fastest way. Good question. How did we know that E for reduction was greater? So they had to give it to me in the question, but they gave me in sentence form, not in simple visual form. So they told me the reduction half cell carries an E value greater than 0. Yep, and if electrolytic, it'd be negative, exactly. Yep, and how many hate that when you find it hidden in plain sight? I do this all the time. I never look in the obvious spot. I always think it's hidden somewhere. Just one of those, whatever. And so if I start recognizing a pattern, a behavior pattern myself, hopefully I can change it. And in all seriousness, how many are guilty of not looking for the most obvious spot? You always try to find it in a crevice. Yeah, we think if it's valuable, it must be hidden. And this damn test hides things in plain sight. And I kick myself for not realizing that. Okay, the greatest voltage would be what? So I need to figure out, it's something to do with concentration. Would you agree with this? And it's also something to do with the half reaction. So let's just do zinc, copper, and nickel, silver. So silver with nickel. This one gets reversed, so that becomes positive. You agree that's going to be 1.03. And then zinc copper, 3, 4, 7.6 goes that way. So this is going to become positive. So 1.10. How many are okay with that? How many are okay with, oh, why is it reversed? Because a couple ways I know this. Number one, a cell has to be oxidation reduction. And so as written, which comes first alphabetically, anode or cathode? So these are drawn anode, double line, cathode. And which comes first, reactants or products when you write it out? Anode reactant, anode product, cathode reactant, cathode product. So zinc going to zinc 2 plus, is that oxidation or reduction? Oxidation. And then copper 2 plus going to copper, reduction. So I must reverse the zinc, keep copper as is, reverse the nickel, keep silver as is, reverse the zinc, keep copper as is, reverse the nickel, keep silver. Okay, so that's why I'm reversing it. And that's where I got these numbers. But then without going into the Nernst equation, I want you to answer just conceptually, what do you think is going to give me more energy? Lots of reactant or lots of product? Which one do you think is going to help me to get more energy out of it? Having lots of reactants or lots of products? Okay, so we want reactants. Let me make that little note. We want reactants, which means we want the solid and the ion, because those are my reactants. So I want lots of this and not lots of this. So does that make sense that I want 1 molar of a reactant as opposed to 1 molar of a product? So my best answer is the zinc copper because it's a bigger number with more reactants. Okay. That said, how many need the math? How many are like, screw that, give me my math, damn it. So let me do the copper one, the Nernst equation. Nernst equation is either reaction is going to equal E naught. Sorry to put that dot in there. E naught plus, it's plus a negative, so I don't know why I'm doing plus, but plus a negative 0. So plugging in, we're going to get 1.10 minus, in this one, 2 electrons are being transferred. So it's 0.03 because 0.059 over 2 log of products or reactants, 0.10 right there over 1.0 right there equals 1.10 minus 0.03 log of 1 over 10, which is -1, so 1.10 plus 0.3. Let's skip the step there, but it becomes plus because how many learn a number less than 1, log number less than 1 is negative? Negative, negative means positive. And how many also learned that I missed a 0? So 1.13. Math or intuition comparing products and reactants, which one works better for you? They both give me the right answer. They're both valid methods. I'm pushing intuition every chance we get because math is arduous. And you know, I think that's true for everybody. I mean, I'm a big proponent of know the math one time so I can take shortcuts in the future. That's the big thing. So hopefully this seems okay. So I had to get E naught, which I got from the table, reversing this one, leaving this one as is. Oh, perfect. So in other words, then you were right there in one small tinkering and you're now all the way there. And so honest answer, did you try to do the Nernst equation and eat up way too much paper and way too much time? Oh, okay. So that's what, I'm assuming that's where that one went. Yeah, but good reasoning. Trust your reasoning skill. It's going to be right most of the time. Occasionally there's a mistake, you live with it. Okay, this is also Nernst equation, same thing, but worded differently. So again, I have to figure out which one of these is going to have a 1.1, an copper anode or a zinc anode. So which one do I need to reverse to make this work out? So if I want a positive voltage, would you agree I need to reverse this one? So I need to reverse the zinc. So I need a zinc anode. And I need a copper cathode. Oh, you're welcome. So, okay. Second, that adds up to, again, 1.10 volts. So do I need more or less volts? I need more than 1.10. So therefore, do I need more reactants or more products? More reactants. So for oxidation, this is my reactant. For reduction, that's my reactant. For oxidation, this is my product. For reduction, that's my product. So ideally then, I want a lot of reactant and little product, which means that's my best choice. Is 18 the same as 16, but written differently? Is it pretty much the exact same question, but screwed by changing the way it's presented? And there's a method to the madness, because I don't know how they're going to write their questions, but if you can write the same question 2 different ways, that helps. Yeah, so this one is totally screwy. So the other notation, let me go back real quick. This is formal cell notation they teach, which this is always anode before cathode, oxidation before that, reactants before products. This one is screwing with you notation. So in this one, yeah, this isn't reactant to product. So it's just screwy the way they've done it. So it's different. It's just the presentation is not the way it normally is. So this is a screwy way of doing it. You know that anode would have to be oxidation. You have to recognize zinc is going to zinc 2+. And that was an extra mean thing. Honestly, that was probably excessive meanness on my part. Okay. One last one, our physics one. This one sucks, but it's viable and reasonable for them to do. Question, what is the equation for kinetic energy? Simplest equation, 1/2 mv squared. Is that going to help me in any possible way in solving this? I think it's going to help me with the 1/2, and it tells me I got to figure out the V. So this is where the V is going to kick in. When you have a cyclotron or anything with circular pathway, when it moves in a circle, I need circle force. The force moving around a circle, QV cross B, that's magnetic force, mv squared over r. Can I solve for velocity using that relationship? So remember my big speech, derivations suck, you'll never need them, don't worry about it? I lied. On rare occasions, do they have a question that is a derivation of some screwy little thing. And how many have taken the MCAT will agree there's a setup question every now and then. You have to figure out how to set it up. Units are usually my saving grace. I've gone beyond the realm of good taste when you put B in there because I don't know B units off the top of my head. So kind of screwed, got to go through the derivation. Yeah, you got to do it every now and then. So V's are going to cancel, one of them at least. And V is going to equal ultimately then QBR over M. Would you agree with this? Now can I plug that into that equation and I'm good to go. So tell me about the 2. The 2 should be in the numerator or denominator. Who's going to stay in the denominator? Perfect, which means I can get rid of E through Z. And I've narrowed it down to just A, B, C, and D. So dang it. Good thought, didn't help me at all. Okay, but plugging in, if I'm putting an M on bottom and it's V squared, do you agree the net result is M is going to be on top or bottom? Ultimately, M is going to be on bottom, so I can at the very least get rid of B. And now I have to work out. You agree it's got to be a Q squared, a B squared, and an R squared. Because of that V squared part, that's my answer. Is this a Shaddam question? So tough I needed 2 profanities. Occasionally there's questions like this. I mean, just I got beat up emotionally, I got beat up by this one, but somehow we made it through. So Shaddam. Sure, if I write it all messy, you won't be able to read what it says anyway. Oh, can I go through how I came up with the profanity? Oh, okay, sorry. I thought you were more interested in that, but yeah, let's go back to the very, very get-go of this one. The few things my tiny little mind knows bare minimum, but here's what I do know. I know that kinetic energy is 1/2 mv squared. And I know a cyclotron is something that spins an electron or proton or whatever it is, ion, in a circle. F equals ma, circle-wise, is mv squared over r. So I know that's a circle portion of it. And I know the magnetic force, charged particle motion moving through a magnetic field, is the 2 magnets, when aligned correctly, exert a force. So QV is one magnet, B is the other. This, I think, is the hardest part of everything. Knowing the force is QVB, memorizing magnetic force, but also knowing that magnetic fields move things in circles so that it's mv squared over r, not just straight out ma. Yeah, so this part, good on that. So that's the first thing you wrote, made sense. Was this the tricky then? That once you get this, things are easy. Yep, so you could tell from the QVB. But mv squared r, that's the v squared is what the tough part on this one was. And so if you got v, that's good shape. Yeah, it's been a while. Sorry, I need to kill my phone just a second. My apologies for that. But we started at 417 and last one, we are actually done amazingly 2 hours and 4 minutes. So just because we started late, we went a little late. So woohoo! But hopefully this seems okay. And again, thank you guys for sticking it out. And seriously, I'm so impressed with how well you're doing right now. And this is the grind period. This is where you've hit your stride. So how many are actually starting to make good progress? You feel yourself learning. I mean, it's just, yeah, maybe not perfectly. And the thing is, because again, you're pre-med, so if you get 92% right, you see that it's 8% wrong and you beat yourself up over 8%. Yep, and that's part of it. And you learn as you go. And how many have started to go numb that, yeah, you miss a few, that's life. Yeah. Oh, it's so easy to fall behind on this thing. But hopefully you as a person are growing. And I know it sounds so cliche, but seriously, and the fact you support each other, I'm so in awe and impressed by. So the company that I love and started that has fallen apart, it's you guys have more than made up that gap. It's just amazing. And I'm bummed that not everybody from class comes to office hours and takes part in everything, because if they could feel what you're presenting, it's great. And again, please stay in touch with each other long after the course is over. Keep that Discord page alive for when you apply and help each other out. Because how many were really moved by Parker being there? How many were just just that's so cool that she was there early on? Yeah, she shows up every time and just throws a bunch of positivity on the pile. And it's just great. Same with Sarah and some of the other people from back then. And fall course, for whatever reason, I don't know why, but fall course is always the most tight knit of everybody. It's always the group that meshes and helps each other the most. And I think honestly, because most of you are older and you've been through the BS and you've been through the stress, and you're on a mission, and you realize you've been outside of school long enough that realize that teamwork actually helps more than competition is great. Negative competition is horrible. Teamwork competition is better. Anyway, I'm seeing it, and it's just really, really cool to see it happening for you guys. So anyway, enough of the little spiel. I'm just keep doing what you're doing. And tomorrow I'm doing fluids, and I apologize because I know I originally had circuits and fluids on Friday, but somebody asked because they can only make one of the 2 days, and I basically bent to their will because I have no spine, and I will bend to your will if you ask with enough authority. So, and they didn't pull the authority thing, they just asked. And I think on the list that's coming in when I add stuff in, now that you've been through the NMR, is it worth dedicating a whole lecture to NMR, or should I save that for something of different importance? Perfect. So hopefully, and I don't know what you're talking about with that. What do you mean you'll be able to do that? Because I don't know. I don't know anything about the looking at things afterwards. But okay, so NMR is good to go. So we'll pile in something else. Yeah, we pile in that. Oh, no worries. I'm just being me. Okay, we're done. Have an absolutely wonderful night, and